Guys, so today is April 6th, and I'm going to do another Leak Code Daily Challenge. So let's start. Okay, so today's problem is partition equals subset sum. Um, yeah. So I've done this one before. Hopefully I could do it again. Let's see. Let's see. Given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal, or false otherwise. Okay. Um, Interestingly enough, this is the first, or how many days daily problem? So I'm on like a 90, I've been doing daily problems for like 97 days. And this is the first time I'm doing a problem that I've already done in the past. So I mean the past 97 problems, I've been learning something new each time. So I guess this is cool because it's just gonna kind of review what I should know, right? Like I did this problem in the past, so technically I should be able to do this problem. And yeah, initially when I read this, well, okay, so what happens, right? So we're given an array of nums, 1, 5, 11, and 5. Okay, return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal, or false otherwise. Um, I think, hmm, I think one observation that we can make is that if we need to split this up into two, like, what is it? If we need to split it up into two subsets, what that means, and both subsets are equal, that means we could take the sum, right? We could take the sum of the nums array and divide it by 2, and then that's how much each of one of the subsets needs to be, right? So if the sum is like the total sum and one of the subsets is the half, right? That means the other subset will be half. And if we add them together, it will be like the total sum. So our target in this problem is, so in this specific example, this is 22, right? So we have a half, maybe I could call it like a target. We have a target of 11. That means once we find some sort of subset that has a sum of 11, we could return true. And I think what will have to be done here, is we're just going to keep track of all of the subsets that we've used so far, I think. Maybe I should explore that a little bit more. So if we had like 1, 5, 11, and 5, maybe I'll rewrite that again. 1, 5, 11, and 5. And then we have like a target of 11. That means once we hit 11, we're good. And then I guess we could have like a current index, I. So I guess in the very beginning, I by itself. So we'll put I here, and then we could have J loop until stopping at I, right? Um, Oh, or maybe we could just have like a bunch of like subsets that we've seen in the past, and those subsets like could start with one by itself, and then once we're at the new index, like index one right here, we see a five. So we should look at all our subsets and add the five to it. Yeah, and then so in these subsets, it's actually like to visualize it, we could visualize it as a bunch of different subsets. But in reality, like under the hood, it's just going to be sums, right? Because that's all we care about. So when we look, it's just going to be integers. And then we could do 5 plus 1 in 6. And we could store it in here. And then there's other optimizations we can do where we always make sure that all the values in the subsets are less than the target. We don't want to add, like, if we saw a sum of 15, we don't want to keep going on that because our goal, remember, is to reach half. Okay, so I think that's a good starting point. So one thing we should be doing is getting the total sum, right? So the sum of nums is our total sum. And I guess one more thing is if the sum is odd, we can't really separate it into two subsets that are equal, right? So we kind of need to check that total sum is even. So we could say if total sum mod 2 is 1, right? So that means if it's odd, we could just return false right away. So like at this point, total sum is even. We're good to go. We just need to find maybe like the target. Our target, like we said before, is our total sum divided by 2. Cool. Maybe I could just have like a bunch of like subsets, which is just an array that stores subset sums less than the target value. Okay, and then I guess we could just do for I in range, or just for I in nums. For each value in nums, we want to loop the, oh yeah, this is totally fine. We could brute force. So we can loop the nums array and then loop the subset sums for s in subsets. If val plus s equals target return true, that means we found, or in this case, we found an 11, right? And I guess we need to check what if that number is 11 itself. So I guess we can do that. If val is equal to target return true, otherwise, let's loop all the subsets we've seen to this. Else, if val plus s less than the target, let's go ahead and add it to our subsets. Subsets.append val plus s. Right, after we loop everything, if we've never seen target as one of the subset sums, just return false. Okay, awesome. So that worked, and I'm going to go ahead and submit. Oh. Oh, I was not expecting it to be wrong. Okay, let's see why it's wrong. 3, 3, 3, 4, 5. Let's start out by getting the total sum, which is 9, 10, or 9, 14, 18, right? This is 18. So that means our target is 9. Once we get a 9, we're good. And oh shoot, what am I doing? And I outputted a false, but we're actually expecting a true. So let's see. Oh, wait, in the very beginning, when we're at when we have a 3 right here at the first at the 0th index, our subset is empty. Okay. So we should add subsets dot append the value itself. I think that's what I'm missing. Okay, cool. Yeah, I mean, I was gonna walk through this, but it was obvious, right? Like I'm looping through something that's empty, which it doesn't make sense because I'm really hoping that stuff gets added to our subsets, but that's not gonna happen if it never loops. So instead, something we have to always realize is that when we are at an index, that value in itself is its own subset. And where am I adding that if I just do this? We need to have a separate case that just adds that value, that like subset of itself into subsets. Okay, so let me submit that. Okay, and then not working again. Huh, this is strange. 2, 2, 3, 5. What is the total sum? 12, right? That means we have a target of 6. And I outputted true, but that shouldn't be the case. And that makes sense, right? Because where can we make a 6 out of this? We can't. But I don't know why I'm putting true. In this case, let's actually walk through this. So we first start out here. The value is not the target. S, there is no subsets originally, so it's not gonna go through any of that. We're just gonna append value, which is 2. So our total subset just has 2 right now. Okay, and then we're gonna move on to the next index. That's not the target for S in subset, so we're just gonna loop through just this one, 2. If 2 plus 2 is equal to the target, it's not. Also, if value is less than the target, then we could append 2 plus 2, which is 4. And then after all of that, we can append the 2 right there. Okay, now we're at 3. 3 is not 6. For S in subsets, value plus s. So if adding 3, that's a 5. That's less than target, so I do that. That's a 7. And that's a 5. Huh. Why did I output true? I guess what value and what s made that true? But why would we be at a value of 2 when 4 is inside our subset? Um, okay. So this part just means I need to, I made the same mistake in the past before. It should be for I in length subsets because I'm appending to it. Subsets at I, like this. And then this is subsets I. And then this is subsets at I. For length, for I in range length of subsets. Cool. Yeah, hopefully this passed. Let me make sure it passed first. Huh. For value in nums. Oh. Oh, okay. If there's duplicate, oh my gosh. I'm really like, I'm really choking on this problem. But I think memory limit exceeded because um, we have a lot of repeated sums. You could see like when I started like actually jotting out what would be in our list, you see like 5 appears multiple times or 2 appears multiple times. That's not super helpful, right? Like we don't care about what two or what subsets led up to the sum. All we care about is the sum. And we know that that sum should be distinct, right? So something that we can do is actually turn our subsets into an actual set just so that there's no repeats. Um, Yeah. Yeah. So this is gonna turn into set. And then maybe I could just have like a current set just to store all the stuff that I'm going to add later. We're definitely gonna have the value is going to be part of it. Um, we could do for s in subsets if val plus s is equal to the target, return true. Else if value plus s is less than the target, then we just have our current set dot add val plus s. There we go. After all this, we kind of want to combine our like big subset, right? So we want to like combine subsets with the current set. And wait, let me think. To do that, we could use like set operators or set operations, right? We could do subsets or equals, right? Or cur set. I think we could do this. So this would just combine the two sets and bring it all into subsets. Let me go ahead and run this one. Okay, that worked. Here's like my like fifth attempt. Okay, awesome. Um, yeah, I mean, I see why this is I think this is one of those like this was in the grind 79 questions or whatever. And it makes sense. I mean, there's a lot of things to learn from it. Um, yeah, like I think the general idea I had it was there, but there were like certain optimizations that I was missing. And then I keep doing this thing where I in Python I call like for s like I get a number in an array, but then I also like append to that array, and then all of a sudden this becomes like infinitely looping. So I need to make sure I code better because that was like the first couple submissions. This was the problem. And then also for the memory problem, using a set is a lot better because we don't want repeated building sums. That would just become like a memory limit exceeded error. So yeah, I mean, I already did this problem before, and yeah, it was cool because I don't really remember, to be honest, on this specific problem, the only thing I remember is total sum and then having to divide it by two, and then wanting to find some subset that equals half. But that's pretty much what the instruction says already, and that's what I kind of remember doing. But like actually getting each subset and using a set, obviously I didn't remember that. But yeah. Um, so I'm trying to think of the complexity. I believe it's n squared, right? Especially if we're using a set. Um, I believe it's n squared, but I'm not 100% sure. And then space is n squared as well. Let me see. Whoa, 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 whoa. Why is everyone using DP? Actually, let me ask Grok. So I need to know. N times S. Oh, 2 to the N. Oh, maybe it's 2 to the n. But I guess 2 to the n is fine. It's 2 to the 100. Oh. 2 to the 100. I don't know. I don't know. Honestly, I don't really know the time and space. But yeah, anyways, see you guys tomorrow.